Every day, millions of people turn to online communities to cope with depression, ADHD, OCD, or PTSD, but the language they use overlaps in ways that makes these conditions notoriously hard to distinguish even for trained professionals. So MindGuard is our answer, an AI system that classifies mental health, text with clinical level precision and responds with empathy rather than a generic chatbot reply. 87,000 Reddit posts, body text only, drawn from 5 condition-specific subreddits. The challenge is that symptoms generally overlap. Someone with PTSD often presents anxiety markers identical to OCD. That's why a single model or a single technique is never enough. We applied 5 distinct AI techniques where the module requirement was 3 to systematically push classification quality as far as it could go.
Starting from a TF-IDF and SCM baseline in the low 70s, we fine-tuned BART and NanoBART and combined their prediction in an ensemble voting classifier, reaching 90.4% macro F1 on our held out test set. We validate the improvement with the McNemar's test to confirm it wasn't chance. To understand why the model makes each prediction, we applied SHA p-values analysis on the SVM and attention weights visualization on BART, giving us interpretability alongside accuracy.
The ensemble got us 90.4%, but what if the model had seen almost no labeled example at all? That's the premise of future transfer learning. We added a pre-trained language model using prototypical network principles, training on just a handful of examples per class, then evaluating on completely unseen posts. The result was 93.3% macro F1, exceeding the fully supervised ensemble. This matters because it means MindGuard could be adapted to new conditions with minimal label data, a real advantage in mental health where labeled clinical data is scarce and expensive to produce. We also ran a rigorous text augmentation experiment, synonym replacement, back translation, randomization to see whether inflating the training set would improve robustness. The honest result was negative 0.07% F1, no improvement. We are reporting this because in AI research, negative results are as important as positive ones. Our dataset was already large and diverse enough that synthetic augmentation added noise rather than signal. Knowing what doesn't work is part of building a trustworthy system.
Classification is only half the system. Once we know what condition a user is likely describing, MindGuard must respond with empathy, not a list of symptoms. We explored 2 approaches. First, prompt engineering on a base LLM. A carefully structured prompt lifted response quality from 74.8% to 78% on our evaluation rubric. Second, we fine-tuned the gamma model using LoRa low-rank adaptation, which updates only a small fraction of the model's weight, making it feasible on a single GPU. The LoRa model generates responses that are measurably more empathetic and contextually appropriate than the prompt-only baseline.
MindGuard is a working product, not a notebook. The backend is fast API service. It takes a text input, runs it through our ensemble classifier and routes to the LoRa tuned response generator. The frontend is built in a Next.js. Here's the landing page. A user types their post or message into the input field. The system returns a predicted condition label, in this case depression, with a confidence breakdown across all 5 categories. Below it, the empathetic response generated by the fine-tuned model. Notice how it acknowledges the user's specific language rather than giving a generic reply.
MindGuard demonstrated that applying multiple AI techniques, classical ML transformer fine-tuning, ensemble methods, few shots learning, and LoRa produce results that no single approach is achieve alone. 93.3% classification if found that empathetic context-aware responses, a deployable full-stack product.